the guide will show you how to install the formats. The formats are actually in a data set in the transport files, but it's a easy step. So once you format the data, you don't really need to, well, when you print it out, you can see the formatted values, but when you're doing analyses, you'll want to know what the visit codes are. And that's in the documentation also. The key variables, the subject identifier is called DID num, and that's because they've been de-identified. And visit is the visit identifier. So like I said, most data sets have one record per DID num and visit. But like I said, you can have, like for baseline, you can have 0, 4, and 5. Those are 3 separate records. Okay, and now I'll just talk about some of the data sets that you might want to use. I've lost count now. We have a lot of them. So subject 1 has the subject level data, and that's just 1 record per DID num. And like I said, that has data for all the screen subjects, but you'll probably just want to use the randomized or those who started intervention. Then IBRS RAND has the randomized treatment arm, which is called TX. And the other data sets I'm going to talk about have 1 record per DID num visit. So, for example, we have clinic weights. That we actually have 2 data sets for that. CLWT long has records for each individual weight that was taken, and then CLWT viz has the average over each visit. Then DXAA is the body composition via DEXA that has things like percent body fat, fat-free mass, bone mass and density, and so on, overall, and like for different sections of the body. TEERQ is the data set that has the TEE via DLW. There's a data set for RMR, core temperature. There's actually two data sets for laboratory assays. The one I listed here is flat, 1 record per subject per visit, but there's also a long one if you, with 1 record for each assay. And then we have a data set called %CR, and that's the calculated caloric restriction based on TEE and changes in fat mass and fat-free mass. And this data set has records per DID num and interval, and not visit. So there are 10 intervals, baseline to month 6, baseline to 12, month 12 to month 24, and so on. Okay, and yeah, that's just a brief sample of the data sets we have. There are several more, and you can find them all in the documentation. The guide to the public database. And like I mentioned, this is a de-identified database. So all dates have been removed and converted to days from a reference date. And the reference date is for CR subjects is the date that intervention started. And for subjects in the ad libitum arm, it's the day after randomization. And that's the end of what I have. And now Carl's going to show some actual examples. Do the sharing thing, and then
So
I'll stitch it
here
up.
on Quick Start.
Yeah, quick start. And share.
Sure.
Yeah. Oh, you probably do this.
That. Let's see.
Okay, that's you.
Yeah. So we start. You plugged in? So, when I was a budding statistician, I was given databases like this in order to do analyses, and I found them terribly confusing, and found them and although waking up in the morning and typing the word SAS into a computer was a good day, it was a frustrating day for me because I ended up having to figure out database management issues. And this is the CALERIE database, and this what I'm going to talk about is a direct reflection of a conversation I had with, or we had with Evan, as he tried to use the site. And as you can see, the database is complicated, and so I wanted to kind of give you an example to try and make it a little easier for people to use the database and figure out. If you're a budding researcher and don't have gray hair and or a data manager to assist you in this, then this is how this is an example of the kind of program you'll write. Now I've put this on what I'm going to talk about on the website. Let's see if I can do this. So right in there is what? Oh, come on. Right in there is the program that I've written. And so if you want to have a good example of this, then it's on the website, and the program I'm about to use is right there. It says there's a program, a SAS program to use, and it can be found here. This is the program you're going to see in just a few minutes. So back to the website. Back to the and so back to this. So if you were to use the website and only care about using data that you're going to analyze from the website, then the kind of database. I'm going to give an example of VO2 max, and I think that this paper is the results here will vary from what is about to be published in Susan Roussette's paper, but I picked VO2 because it's Bill's favorite variable. And so what are the steps you'd want to use? First, you'd like to find the variables in an analysis data set. You need to realize that this is a relational database, so that some of the variables there are many databases, but you need to find the linking. The linking is going to be found by either merging on the basis of the identification number, or by linking on the person visits. So and then you have to make a decision as to whether you are what kind of data file that you want to analyze. So database people think in terms of two different types of databases: short and fat, and long and skinny. Short and fat means it's at the level of person, and the different measures over visits are spread out. In order to do that, to uniquely identify them, if you were doing VO2, then you'd have VO2 at time 0, VO2 at time 1, and you'd need a unique name for them. Alternatively, you can have a database that's long and skinny, and this is at the level of person visit. And so in general, most programs want to have the database in a long and skinny format. So how are we going to get it into a long and skinny format? Well, it comes in a long and skinny format, and we're just going to do, and again, because it's a relational database, we're going to do merges. And so if some variables are measured at the level of person, and some variables are measured at the level, come in terms of the person time, then SAS is smart enough, and most databases are smart enough to do what's called a many-to-one merge. So you have one person, have 5 observations on them, it will merge them in that way. So what I'm going to show, what I show here, and I'm going to try and get us back on time, what I show in the program I do, will build a long and skinny data set, and it'll build the short and fat data set. We need the long and skinny to analyze things that are measured over time. For example, if you're going to use proc mixed in SAS or any of the multi-level modeling, you need it in the long and skinny format. If, on the other hand, you need to calculate change scores, and if those of you who have read our papers see most of our data, most of our analyses are analyzing change, then we need it to start in the short and fat way because we have to get observations. If I'm going to subtract your VO2 at baseline from a VO2 at time 12, I need to be able to subtract the two, and so I need to get them on the same line in code to get that done. Similarly, so my program does two things, and I'm not going to show I'm not going to go over the program, but it does two things. One is it shows you how to move data between short and fat to long and skinny, and second, it shows you how to it gives you sample analyses that can occur in the long and skinny. So using proc mixed, then it converts it to the short and fat, calculates the change scores, and then from the change scores, then you go back to the long and skinny, where the where the outcome is then the change score, because you have multiple change scores. Here in VO2, or in most of the papers coming out of CALERIE, we analyze 0 to 12, 0 to 24, and so we have those two observations become the center of the analyses. So I'm going to show the program will show how to calculate change scores, how to create a baseline variable on the variable of interest, and then how to control for percent CR. The percent CR, if you read once you get into the guts of the program, is an interesting one because that is one that's not measured at the level of visit. We have multiple CRs, but we have CR from 0